Right. So this is about the cool things about light. Now you also see that take a stock of this. Max Planck gave in 1900s, and he was a guy who was really talking about particle nature. Slowly it was confirmed, and it was further confirmed by Albert Einstein. For your information, what is the first invention of Albert Einstein?
On light quanta.
Light quanta is second one.
Black body.
Black body is also second one. This is all light quanta is coming from black body experiment. E is equal to mc squared. Relativity theory. Relativity theory, I'm giving you the answer. But for that you need to get the Nobel Prize. He got the Nobel Prize for the black body, otherwise for quantum effect of the light that you have seen it, right? So later on, Planck has given you the law and giving you about spontaneous radiation and the induced radiation. 1920s, you had a quantum effect, which is where you can talk about photons and de Broglie relationship, uncertainty principle, Schrödinger talking about energy expression. Finally, the quantization. Quantum mechanics told all about the atoms, but if you look at the Dirac, just given you about quantum electrodynamics. This is how the light, the people have worked on the basic science of light, right? They've given you a lot of ideas. What is light? Now, what is light? What is electron? Electron, if you summarize it, it is negatively charged. The mass is very less, and it is having the momentum. Right? It can be accelerated. But look at the photon. Photon is also dual nature, as you see in the case of electron, but it does not have the momentum. It is not negatively charged. It cannot be accelerated. It is always traveling with the constant speed. You can slow down the light. Refraction. So why do you think the refraction phenomenon is happening? You can slow down the light. How do you slow down?
Traveling from one medium.
Right. Why one medium to another medium? Denser medium. Optically denser medium? No. Light should not be absorbed there. It is not it is optically transparent medium. It is not optically denser medium. It is traveling from a denser, lighter medium to a denser medium. Why light has to refract? Why light has to refract? Do you have an answer for that? Have you ever, why speed has to slow down? What interaction? That is how the question goes. That is where science is going. What obstacle? If I want to pass through that between you, it is difficult for me to pass through, right? Light has to take a dilly-dallying routes.
Speed of light is
How? Who is the disturbance? Changing medium, why? It's traveling in a straight path, yes, like this. Right, what you are saying is right. But the real answer is, there is an interaction between light. Now, which part of the light? When I define light, it has the electric vector and the magnetic vector. That is what we call it like an electromagnetic radiation. Now, you have the electric vector that is trying to interact with the material. What is the material? It is a denser medium, for example, glass. Glass that you are using it. What is it made of? Silica. Right. It's again another soil. Another form of the soil. Silicate structure. Not exactly silica, it's a silicate structure. Silicon, oxygen, silicon, oxygen. You can see the electronegativity difference. There is a dipole. Light is a dipole. There is a dipole-dipole interaction. Attraction, repulsion makes it to slow down when it goes in denser medium. That is what is really happening in the refraction when the light is interacting with the materials. You can see now the electromagnetic radiation, whole gamut of light that you are getting in. It starts from radio frequency to gamma rays. So what is radio frequency? Energy, see, that's the lowest energy you can carry. And highest energy you can carry is gamma rays. And in between you have an interesting energy source, visible, infrared, ultraviolet, and you also have the visible region, visible, ultraviolet, infrared. Now what is the source of this region? What is the source for this, do you think? And each one, if you look at it, shorter wavelength, you can study about atomic, nuclei, atom, proteins, virus. Here you can talk about the interaction of the matter with light, right? And you can slowly see it, many interactions. We also use a microwave for communication, radio frequency for transistors and radio waves, right? So many frequencies we use it. But there is one light source for the visible, IR, and ultraviolet radiation. Which source do you think? No answer? God's Son. Nobody else. The beautiful God's Son. Right? He is the source of the light. And what kind of light you get? Again, electromagnetic radiation. It's the electric vector and the magnetic vector. Now, what is the region of light that you get out of the sun? You can see that starting from ultraviolet, going up to infrared radiation. Right, infrared radiation, you can see it, mostly water absorbed here, and you can see they are dense, intensity is very high around the blue region, 450 nanometers, you get the very huge intensity of light from the sun. That is where you can see it, your natural systems are absorbing light. You see it? So, the sun, the plant kingdom has a correlation. They have a communication. They communicate very well. Why plants are to be green? Well, why not it is red? Why not it is blue? Who has divided it to become green? Chlorophyll. Who has created chlorophyll? That is what is the nature. And if there is a correlation, the light is being absorbed in this region. Beautifully, it absorbs in the blue region. Right? So, blue color material absorbing blue. It's a complementary colors, you should know it. They are very nicely absorbing the most intense region of the solar system, and that is the reason why they all have a chlorophyll as a pigment. They are absorbing in the region. Fine. Now we talked about the basic particles, electron, photon. Now the next level of understanding is when they interact with the matter. When the electron is falling on materials, when photon is falling on material, what really happens? Look at this electron. Electron falls on the materials. It can do many phenomena. It can produce again electron. It is basically called as the secondary electron. You can have the secondary emission of the electron. You can have the older electron. You can have the light coming up. See that the electron is producing light from the material. That is very interesting. I told you here, thermal electron that you get out of the tungsten is exciting the gaseous molecule mercury. Same way you can see it, light is coming out of it. You also have the X-rays coming out. X-rays can be used as a source of characterization of the crystalline materials. X-ray diffraction, X-ray crystallography, they do it. Again, they have the source of the X-ray. Electron is beamed on that and you get X-rays. Again, you can analyze these X-rays called the index. Energy dispersive X-ray, you can do it. Again, the secondary electron is used to image the materials, image the surface. That is what is called the SEM. SEM is called the scanning electron microscopy. And you can also transmit the electron. If the material is very thin, you can also transmit the electron. You call them as the transmission electron microscopy. You can also have the diffraction crystallography and ELS, electron energy loss spectroscopy. So like this, just a single electron falling on the matter, you can do many things. Right? See the importance of electron. Now if you realize that J.J. Thomson has not given you the electron, what would have been the story now? I think you know about it. You cannot characterize the materials. Now people are able to characterize the materials because Thomson has given you a foundation. If you want to construct this building, what is required? Space is one thing. Foundation. Without foundation, do you think building will be stable? No way. So, technology, foundation is science. Materials, organic materials, now organic materials have taken a big leap. Not only that, you see the solar energy conversion system, semiconductor device, silicon technology, gallium arsenide technology, and it is electron to light. Their light to electron is the reverse of that. LEDs to the solar systems are reverse of this. You have to trap the light and convert the electricity. So people are still working. Now, as on today, we have the efficiency of 20%, but still it is not effective. Cost is very high. People have to have the low-cost solar system so that people can use it, and which can be a replacement for all your fuel-based technology, like a coal-based technology, all your nuclear power technology, right? So nuclear power, we know, Fukushima accident has turned the mind of the people, right? We should not have any more nuclear power. But if you talk to India, India says the nuclear power is a real alternative. But it depends on the technology, right? So that is where people have to find an alternative technology. Again, if you know the property of electron and photon, only you can do this. So without knowing the property of this electron and photon, you cannot do it. And when I go to the photon, when I make it to fall on the materials, what is happening? It is absorbing light. They absorb the light. There is a basic law of governance called the Beer-Lambert law, which measures about intensity of transmitted light. You can always correlate to the absorbance. It's called as optical density or absorption or absorbance, which is equivalent to epsilon Cm. Epsilon is the molar absorptivity of the material, concentration of the material is C, M is the optical path length. When you look at the measurable parameters, intensity of incident light, how much of light is transmitted. They take the ratios and logarithm, that gives you the absorbance. Like this, one can measure how much light is being absorbed. You know, I also want to measure how much you absorb in your classroom. Is there a scale? Is there a law? Is there a rule of governance? No way. Only the people think, oh, Mark is your real ruler. No way, that is also not true. Right? So there are so many things are there when you want to look at how much you absorb and how much you remember, how much you write during the exam, how much you remember after 5 years. When I talk to my students, next semester I ask a question what I taught in the last semester. Sir, I forgot, sir. I talk to my plus 2 students. Oh, exam is over. That's it. It is only for exam. No, don't study science like that. Science is always for the sake of learning. It's a real excitement. Right? You have to enjoy, feel and learn. That is where you feel the science is really growing. If you don't feel a subject and learn it, ஐயோ அம்மா அப்பா கஷ்டப்படுத்துறாங்க அவங்க தொல்ல தாங்க முடியலப்பா அதெல்லாம் படிக்க போறேன் அப்படின்னா that's it, finished. So now when you look at the absorption, what is happening inside the material? We have seen the electron interaction with the matter, so the electron coming out, light coming out. Here, light is being absorbed by the material, and that promotes electron. You see that when light is falling, the electron is interacting. When electron is interacting, light is coming. They are all inseparable. They all go together everywhere. That's why I said big brother and younger brother. They are all, God called them as the twins because they were not discovered in the same year. Otherwise, you can call them as the twins also. Simply say bigger brother and younger brother. Right, when the light is interacting with matter, you can see that the electron going from a lower energy level to the higher energy level. And this phenomenon, we call it like an absorption. We call it like an absorption. And it is also called as the excitation. Right? You always say that, I feel excited. What do you mean by this? You feel energetic. That is what we call it like an excitation. I have given extra energy for the materials. The energy is being absorbed, right? If you feel that, your parents give you 2,000 rupees today afternoon. After, as soon as you go home, what will you feel? You feel excited. Let us go to good hotel and eat. That's an excitement. That's an excitement. More people have it if you have extra energy on it. They absorb. What happens after excitation? You cannot stay on the excited state for a long time. Right? It is a temporary path. It is also temporary, short-lived. It is basically short-lived. How short is that? And you should also ask a question, how much time it takes molecule to go to the excited state? Right, how much time will it take? Electron goes from here to here. How much time? Can anyone answer for that? How much time it takes for the electron to go from the lower energy level to the higher energy level? That is what is called the excitation of the molecule. When the light is interacting with the matter, that is what is happening in your chlorophyll, that is what is happening in your rhodopsin. There is an excitation phenomenon. When the light is falling, yes, there is an excitation. It is continuously happening as the light falls on your materials. So how much time do you think it will go to the excited state? Otherwise, how much time it takes to go to the excited state? Let me ask the question differently. You know the velocity of light, speed of light. How much time light will take to travel a distance of 1 centimeter? Let me ask a question like this. You know the speed of light? Take a piece of paper and calculate and tell me. Now tell me in numbers. Don't say 0, 1, like that. How many zeros you don't know? 6 what? Seconds. 0.8. No, do it slowly, yeah. Don't travel light speed, yeah. You do it slowly and tell me what is the time taken to travel a distance of 1 centimeter.
3 to 10 power minus 10, sir.
3 into 10 power minus 10. Sure? Minus 10 what?
3 to 10 seconds. 3 seconds.
That's the velocity of light. I want in terms of seconds. Distance traveled for 1 centimeter. Tell me in picosecond, that is straightforward. I want in picosecond. I want in picosecond. I want in picosecond. You are hungry? You are hungry? You are hungry? Back part? No. You are hungry? No. வயிற்றுக்கு உணவில்லாத போது சிறிது செவிக்கு நீயப்படும். 33 picosecond. Very good. Right answer. So you can see that it takes only 33 picoseconds to travel a distance of 1 centimeter. You know 1 second. 33 picoseconds. Is it easier? Very difficult to visualize it, right? That is the time it is taken. Now if you look at the excitation, this takes a time of 10 per second, 10 to the power minus 15 seconds to go from the ground energy level to the higher energy level. That fast you can see it, electron is pushed because the energy is quite high. And then it has to relax back. How it relaxes? Let's see, one of the relaxation is absorption in 10 per second. And then they relax, excited, relax from that, thermal modes, again ground state. When they emit light, you get a beautiful emission coming out of the material. And that is what you see as the emitting materials, right? Again run it. You see the beautiful emission coming up. And this is what you see as an emission here. And that is how the materials are emitting light when the light is being absorbed by the material. And that is an interesting behavior of the material. And how much time do you think all this emission will live long? Now you can see the form of a diagram, which I call it like a Jablonski diagram. It was given by Jablonski. So absorption phenomenon and then coming back to the ground state. If they are emitting light, they are called as a fluorescence. We always say that a fluorescent brighteners. We use a fluorescent markers. Right? They are all light emitting materials. See the materials, they are already using. But they have done research. Even before the photons were discovered, this light emission is known. But they didn't know the photon, but no light is being absorbed. That's all. Photon was not coined, the light absorption was known. And then you have a radiative relaxation from a different spin state. This is called a single state. Now when you look at a bond, make a bond between two atoms. What is this bond? Make a sigma bond. And how many electrons do you require? என்னப்பா ரொம்ப போர் அடிக்குதா? ரொம்ப போர் அடிக்குதா? ரொம்ப போர் அடிக்குதா? இல்லையா? ஏதோ அந்த குட்டி மீட்டிங் நடக்குதே, அதுதான் சயின்ஸ் எக்ஸைட்மெண்ட். சயின்ஸ் எக்ஸைட்மெண்ட் எப்போ வரும்னா இன்வால்மெண்ட், சீரியஸ்னஸ், டெடிகேஷன், ரைட்? இஃப் யூ டோன்ட் கெட் எக்ஸைட் அபவுட் இட், பசிக்குது, எனக்கு கூட தான் பசிக்குது, அது ஒன்றும் பண்ண முடியாது, கரெக்டாக 4 மணி நேரம் தான் பசிக்கும், ரைட்?
One
Pair of electron oriented like this, opposite direction, the spin multiplicity is called as a singularity. And if you put it like this, it is becoming a same directional spin. Spin multiplicity is 3, 2s plus 1. You put s is equal to half, calculate the spin multiplicity. So this is what is the situation. Here orientations are the same. One electron is in the ground state, without changing its orientation, it goes to the higher energy level, and slowly it is changing to different direction. That is what is called the triplet state. If it is relaxing from here, it is called as a phosphorescence, provided if it is radiative relaxation. Now you can see the absorption, relaxation in the mode of fluorescence, the mode of phosphorescence. In addition to this, you can also have the thermal reactivation. That is all. They are all happening in a very short time scale. And the fluorescence is always happening in the picoseconds, and phosphorescence is happening in the order of few microseconds to milliseconds. That's it. Right? That is what is happening when there is an absorption. These are the phenomena, you can talk about it. Okay. Most interesting invention that we can say in the last century was lasers. Lasers have given a lot of technology, actually. I just keep all of them. Another interesting behavior people talk about is the materials, quantum dots. This is what is called the nanoscience and nanotechnology. People talk about it. Different size you have it. They have a different absorption, different emission. And material, molecular material that you use out, there is no influence of size. Here is the influence of